So in this video, we will learn about equivalent force systems. Okay, so I'll give some small explanation about equivalent force system, then we will solve this question I have on the screen here. So when I say equivalent force system, what does it mean? So let's say I have a force system here. Okay, I have one force here, I have another force here. Okay, so let me name this my force 1 and then my force 2. Okay, so the equivalent force system, it says that when you have such a system, okay, a system which consists of what? Many forces, okay, two or more forces. It says that what I can represent these two or more forces with what? A single force, which is what? Equivalent to all the forces. So I can represent these two or more forces with what? A single force, which is what? Equivalent to all these forces. So when I have F1 here and I have F2 here, I can represent this with what? A single force. So I can say that, let's say, a single force A will be equal to what? F1 and then F2. So after doing this, you can represent this equivalent force, okay, also on this line of act, this line here. Then this will be my, let's say, FA. So what this means is that instead of writing these two forces here, okay, I've represented it with what? Just this single force here. Okay, so in that case, I can kind of draw the system here again. And then since I aimed at was making it look simple, this will be my point A. And this will make it, this will be the point where the FA is acting, and then this will be what? FA. So instead of me writing this complex system here, I have what? Represented it with what? A single force here, FA, which is what? Equivalent to what? The sum of this force and then this force. So that's what equivalent force system is. And let's also talk about moment. So the moment part here is that these two forces here, okay, the moment of these two forces here from this point A, okay, the moment of what these two forces here from this point A will be equal to what? The moment of what this force about what this point. Let me say it again. The moment of force 2 and then F1 here, okay, the moment of these two forces will be equal to what? The moment of what? FA about what? This point. So if I find a moment for F2 with respect to this point, then I find a moment for F1 also from this point, the sum of these two moments will be equal to what? The moment produced by what? This force A here. So I'll say that the moment in, let's see, let me name it this system 1, okay, let me name it system 1 and this is system 2. So I'll say that the moment in system 1 should be equal to what? The moment in what? System 2. So this will be the moment in what? System 2. Okay, so for equivalent force system, you can represent what? A number of what? Forces with what? A single force, which is what? Equal to those number of forces. And when you do that, the moment of the forces will be equal to the moment of what? That single force about a specific point. Okay, so that's what the equivalent force system is. Okay, so with this knowledge, you go ahead and then solve the question on the screen. So the question says that we should determine an equivalent force system for A at point B and then B at point B. And also, we should determine an equivalent force system consisting of what? A single force only, and then specify the x coordinates of the point where the force's line of action intersects the s axis. Okay, so you go ahead. So the first thing you have to do here is what? To find equivalent force system with at point A. So let's look at what I'll do here. So I'm going to draw the system. Then let me show the forces here. I have one force here, I have another here, and then I have another here. Okay. So let me, this one is 4 Newton, and then this one is 3 Newton, and then this one here is 2 Newton. Okay, pointing upwards. I have 2 Newton pointing downwards. So the distance here is 2, here is also 2, and then here is also 2 from point O. Okay, so now he said what? I should find what? An equivalent force system what at point A. And you see this is point A, and that's where this force is what acting directly. So I can put my point here and then name here what? Point A. So now in this case, this is the point A. Okay, so this is what we should find what? An equivalent force system what at point A. So what this means is that this system of forces here, okay, we are going to what add them, okay, and the result will be what will give the force at what point A, and then you take the moment of what each of these forces from what point A, and then that will give me the moment what of the force at point A. Okay, so I'm going to find the equivalent force. So that will be, let's say, F about point A will be equal to what? This force is pointing the negative y-axis direction, so that what minus 4, and then this is also pointing the positive y-axis direction, so that give me plus 3, and then this force is pointing the negative y-axis, so that give me minus 2. So then I'll have minus 3. Okay, so then I'll have what? Minus 3. Okay, so this minus k, okay, tells us that what the force is what pointing downwards since it is minus. So to be pointing downwards in the y-axis direction, okay, because all the forces were in the y-axis direction, none was in the x-axis direction. So the force about point A, okay, will be what 3 Newton, and it will be what vertical. Okay, so I'll draw another system. Let me draw my equivalent force system here. So this will be my equivalent force system here. Okay, so the force will be here. It is vertical. Okay, and it is pointing the what negative y-axis direction, because we got our answer to what negative. So I have my 3 Newton here. Okay, about what point A. Okay, so instead of rewriting this complex system here, I've represented it with what a single equivalent force here. Okay, at what this point A here. So now that you are done, let's find the moment what that this 3 Newton force will cause about what this point A. So for us to be able to get the moment that this 3 Newton will cause about this point A, we have to what find the moment of what each of these forces here from point A. Okay, you have to find the moment of what each of these forces here from point A. So the first one, let's say M1. So let's consider the 4 Newton force. This is the 4 Newton force. Let's look at it distance from point A. So that will be from this point to this point. That will be this 2 plus 2. So it's 2 millimeters. Okay, so it's millimeter. Okay, so millimeters. So that will be 4, right? So the moment is what the force times the perpendicular distance. Okay, and looking at this point here, this force will move in this direction. Therefore, it will be what anti-clockwise, and it will be what a positive moment. So I have 4 times 4. Okay, so that's M1. Okay, so 4 times 4. Okay, and that'll give me 60. Okay, let's find for M2. M2. So M2, the force is what pointing upwards. Okay, and this is the point here. Okay, so this force is what moving upwards here. So this tells me that what it will cause what a clockwise rotation, therefore to be what negative. And then if distance from the point A is what 2. Okay, so I have 3 times 2. That give me I have 3 times 2, and that give me 6. But since it is in the clockwise direction, to what minus 6. So now let's find the resultant moment. The resultant moment will be 16 minus what 6, which will give me what 10. So that will be 10 Newton millimeter. Okay, so this is the moment that this force is will cause about what point A. So that will be the same moment that this resultant force here what will cause about what point A, and it is a positive moment. So that means A will cause a rotation what in the anti-clockwise direction. Okay, so A will cause rotation in the anti-clockwise direction. So I have something like this. So that will be, okay, let me make it very careful. Something like this. So that will be 10 Newton millimeter. Okay, so that will be 10 Newton millimeter. Okay, so now we found for what the equivalent force system what at point A. So you are going to do the same for equivalent system what at point B. So you can pause the video and then try this one yourself. So let's say I'm going to do this also. So I'm going to draw this system again. Okay, then I'll indicate my forces on it. Okay, let me bring this here. Okay, I have another force here. I have another force here. Okay, and this is where point B is. Okay, so you see that one of the forces is acting directly on what point B. Okay, I have one force here and then I have another force here also. So this is 2 Newton, 3 Newton, and 4 Newton in their respective distances. So here the distance between the 4 Newton and the 3 Newton is what? 2 millimeter. And then here also 2 millimeter. Okay, so I'm not going to consider the distance here, okay, because all the other forces are the right side of this this of the B. Okay, all the other forces are this side, so I'm not really going to consider this distance 2 millimeters here. Okay, so we need what? An equivalent force system at point B. Okay, so this is point B. So with all these forces here, okay, we want to represent it with a single force but at point B here. And that force will also have what? A moment. So when I find the single force here, I must find the moment of what? That single force also. So what will be the resultant force? So I'm going to add all these forces here and then represent it with what? A single force over here. So that will be, let's say, F1 plus F2 plus F3. So that will be, this is pointing the negative y-axis direction. So that will be what? Minus 4. And then this is pointing upward. So to be positive, so plus 3. And then this one also was minus 2. So at the end I'll have minus 3 Newton. So this will be the equivalent force. Okay, so I can represent this all these forces with what? This single force, which is what? 3 Newton here. So the negative here tells us that the force is what? Acting downwards. So I had the equivalent system here. So that's what? Negative 3. Okay, and it is straight because it is straight because all the forces what are acting what in the y-axis direction. Okay, so there's no way that it will be bent. It's the resultant must also act in the y-axis direction. So now we found for the resultant force, okay, which is equivalent to all of this. So now the next thing you're going to do is that you're going to find what the moment of what each of these forces, okay, from point B. The moment of what each of these forces from what point B. So and I'm going to consider all these forces, okay, and then take their moments from what point B. But when you look at this force, you see it is acting directly on what point B. This force here is acting directly on what point B, so it cannot cause a moment on what point B because it doesn't have any distance from point B. The distance from point B is 0 since it is acting directly on what point B. So you consider there's these two forces. So the moment about point B will equal to, let's consider this force. This force is 3 Newton, okay, and this is 2. The distance from point B is what? 2 millimeters. And this will cause an anti-clockwise rotation, so it is what? Positive. So that will be 3 times 2. Okay, and then let's look at the moments of this 2 Newton here from here. So the distance is 4 and then it is moving this direction, so it will be what, and it will be what, clockwise, so therefore it will be what, negative. So that will be 2 times 4. Okay, so that will be what, 2 times 4. So that will be, since this clockwise is what, negative, so I have minus 2 times 4. Okay, so then I have 6 minus 8. This will give me minus 2 Newton millimeter. Okay, so I have my moment to be negative. So this tells me that this force here, okay, this equivalent force system here, the moment will be what? A negative moment. Therefore, it will be moving what, the clockwise direction. So that will be my two. The clockwise direction should be this way rather. Okay. So that will be my 2 Newton millimeter. Okay, so that's the moment about point B here. Okay, so you see how we went about it. So you find an equivalent force system. Okay, so that means you are going to find a force, okay, which is equal to all of this. You are going to find a single force here, which is what, equal to this. So you are going to find a single force here who can perform the same external effects that this system of forces will also cause. Okay, so that's what that means. Okay, so we look at the last part of the question. Okay, so which says that we should determine an equivalent force system consisting of what, a single force only, and then you should specify the x coordinate of the point where the force's line of action intersects the x axis. So what this point C means here is that what, for all these forces here, okay, we should represent it with what, an equivalent force system here. Okay, we should represent it with an equivalent force system here, and then we should do what, determine, we should determine what its distance was just from what, point O. So you're going to represent all these forces here with what, an equivalent force. Okay, and then you should determine what its distance was from what, this point O here. Okay, so when you look at this bar, you see that this point O here, let's say it's attached to a point. So this point O here will be the turning point. Okay, this point O here will be what, the turning point. Okay, so let me draw the system. So I have all this. Okay, one to be here, another one here, and then one here. Okay, so let me indicate the directions. This one going upwards, this one going downwards, and this is 2 Newton, this is 3 Newton, this is 4 Newton, and then this is point O. Okay, so now the question says that what, we should find an equivalent force system consisting of what, a single force only. So the single force only here means that what, we should have what, we should determine what the resultant force. Okay, you should determine what equivalent force system, which is what, made up of what, a resultant force, and that resultant force will be what, the force which will be the same as what, the sum of all these forces here. Okay, so instead of you using this complex system, we've been asked to find an equivalent force system. So this is point O. So this is point O here. Okay, so you're going to locate any point on this system here. Okay, you've not been told the actual where to locate it, so you can locate it anywhere on this point here. So you're going to create another point. Okay, you're going to locate any point, okay, on this line here. So let me make it point C. Okay, you're going to locate a point here. Okay, and you should find what, an equivalent force system was at this point C here. Okay, so you're going to find a force here which will be equal to what, all these forces here, so that instead of you writing these forces here, you're going to represent it as what, a single force what, at point C. And before you do that, you know that you have to what, find the force itself. Okay, so the force that will be at point C, and the force that will be at point C will be what, equal to what, all these forces here. So let me see, the F at point C will be equal to all these forces here. So this is acting down, so that will be minus 4. This is acting upward, that's positive y-axis direction, so that will be plus 3. This is downward, so that was minus 2. So this will give me minus 3 Newton in the y-axis direction, and it is negative because it is what moving the negative y-axis direction. So this tells us that my force here acting at what point C here will be a negative force acting there. It will be a force acting in the what negative y-axis direction. So I have my what 3 Newton here. Okay, so this is the force here. Okay, so we can represent all these forces with what this single force 3 Newton force here acting at what point C. Okay, so what next? The question says that you should what specify the x coordinates of the point where the force's line of action intersect the x axis. You are going to specify the x coordinates of what this point here. Okay, where the force's line of action intersect the x axis. So what this means is that we should find what the distance of what this point C here. Okay, we should find out the distance of what this point C here from what the point of rotation O here. We are going to find the distance of this point C here from the point of rotation O here. So looking at these forces, okay, you see that this 2 Newton force here, it has what a specified distance from what this point O, which is what 6. This 3 is also at a specified distance from this point O, which is what 4. And this 4 is also at a specified distance from point O, which is what 2 millimeters. But for this point C here, you don't know that its distance from a point O. So you are supposed to find it. So that's what you are going to solve for now. So you want to find out the distance of this force acting at point C here from what point O. So let me make this distance. Let me say that will be D. Okay. We don't know it because this force here, okay, we were not given a specific place. So we were just asked to represent all these forces here with an equivalent force system. Okay, so in that case, you just located any point on the system, okay, and then since we've been able to locate any point on it, we found the force acting at that point. And if you have been able to find the force acting at that point, let's find the distance that force is acting on from the point of what rotation, so which is this D here. So with this, you know that what we are considering what this force is here, okay, and their distance from what point O, because that's where they are causing the rotations. That's the point of rotation. So you are going to consider all these forces and then their distance from a point O. Okay. So you want to find the moment of what all these forces was about what point O. You want to find the moment of what all these forces about what point O. Okay, so I'll take the first force, this is what 4 Newton. So look at this 4 Newton here. And its distance from point O is what 2 millimeters, and it will cause this system to move in this direction. So therefore it will what a clockwise motion, so therefore it will what negative. So for the first force, the moment M1 will be equal to what? That's 4 times 2. And since it was clockwise, it will what? Negative. So that was minus 8 Newton millimeter. Okay, so let me find for the second moment. That's the moment caused by the, what? This 3 Newton what? From what point O. Okay, so that will be 3 times what? The distance from point O. That's from this side here to this side. So that's what 4 millimeters. So that's times 4. Okay. So that gives me 12 Newton millimeter. Okay. So this is what I have here. Okay. So now we have to find what the moment of what this force here from what point O. Okay, because that's where they are causing the rotation here. So I'm going to consider the moment of what this force here from point O. So the distance of this force here from point O is what 6. So my third moment will be equal to 2 times 6, and that will give me what 12 bar. Looking at where this force is, it will cause what a clockwise rotation, so it is what a negative moment. So that was minus 12 Newton millimeter. So that's the moment I have here. So MT will be equal to what? Minus 8 plus 12 minus what? 12, which will be equal to what? Minus 8 Newton millimeter. Okay, so what do we do now? So we know that what, since this force here, okay, so since this force at point C here represents all these forces here, okay, since this force here at point C here represents what, all these forces here, or it's an equivalent force system what for all these forces here. That tells us that what, the moment that all these forces here, okay, the moment that what all these forces here will make will be equal to what, the moment that this force what will also make. So the moment of all these forces here, okay, from point O will be equal to what, the moment of what, this force from what, point O. Do you know why? The reason is that all this force system here has been represented with this. Okay, all this force system here has been represented with what, just this force here. So if you have to find the moment of what, all these forces here from point O, it should be the same as we find what, the moment of what, just this force from point O, since this force equals what, all of this. So in that case, we know that what, the moment of what, all these forces here from point O equals what, -8 Newton millimeter. And you know that what, it will be the same as what, the moment that what this force here will cause. Okay, so now that we know that, let's look at this. So now, if I want to find the moment of what, this force here, okay, from point O, okay, if I want to find the moment of this force here at point O, what will it be? So looking at where point O is, this moment move in the clockwise direction, so it will be what, negative. But I don't know the distance here. Okay, I don't know the distance here. You know, moment is what, the first times what, the perpendicular distance, but I don't know this perpendicular distance here. So I can write my moment of C to be equal to what, 3 times what, D. And since it is clockwise, it will what, negative, so it will what, -3, and then D. So that will be -3D. And we know that this force here equals what, all this force here. So if that's the case, then the moment of all these forces here from point O will be equal to the moment of what, just this force what, from point O. So that means this moment here should be equal to what, this moment here. So that will be what, MC should be equal to what, MT. So if that's the case, I know MC to be what, -3D, and I know MT to be what, -8. So I divide both sides by -3, -3. So this one cancel out, this one cancel out, the negatives will cancel out. So let's see what we have at the end. So I now have the D to be equal to 8 divided by 3. So that gives me 2.66 millimeter. Okay, so that's the distance that we are looking for. So this will be the distance that a certain equivalent force system, okay, or the force acting on what, on any point on what, on this will be from the point O. Okay, so now you have been able to what, find the distance that this equivalent force acting at what, point C here makes it what, the point of what, rotation. So that's all for this video.